We streaming?
We're streaming.
That's good. 1 minute. 1 minute.
There's 1 minute
Going
to go.
live on it, 9 a.m. Pacific. We'll be right back.
Okay, we're live. We got one person, 2 people on.
All right, let's just go ahead and go for it. Good morning, everybody. Today is the 16th of April.
16th.
We're happy that you're here with us on this new Tip of the Day Instagram Live. Of course, we've got Mark Terryberry with us. Say hi, Mark.
Hi, Mark.
Mark's got his coffee. He's ready to go. And we've got Andrew Harnett. He's going to check out the chat, and he's going to be serving up some great questions. We're so glad you guys could join us today, Mark. As always, let's start with you. How are you feeling today?
I'm doing really well. Got a good night's sleep. All ready to go. It's 9 a.m., so I've got my my dress uniform on. We were talking about the timing of the live tip of the day here and how people all over the world have different time zones. And so our Russian friends in the Urals, it's 9 p.m. there as opposed to 3 a.m. so they can actually watch this. We'll see what the best time is. If you have a preference for what time you think a live broadcast should be, let us know and we might switch it up for next time.
Yeah, we're probably not going to come in at 3 a.m. though, or anything like that.
I can do it.
Maybe from our pajamas in our bedrooms or something.
Yeah. Although it's we've pretty much all been in our pajamas lately. Those of us that have been working from home, I had to shave this morning, and so my neck is all scratchy.
Looking good, buddy.
Yeah,
Looking good.
yeah. I shaved just for you. That was it.
Oh.
Well, why don't we start off earlier when we came in here getting ready for the show? We were kind of discussing some of these tools we have here on the shelf here, and Mark and I were talking about what kinds of things you can tell, looking at especially these shell mills here. What kind of things can you tell just right off the bat about what those tools are intended to do? You know, without picking up your tooling catalog or anything. What things can you say just looking at them?
Sure.
Kind of no intro.
Yeah. Go ahead and if you have questions coming in this morning, make sure to get those in. Andrew, like he said, is going to be reading those as they come in. But just to get us going, looking at indexable end mills, I've got some of my favorite tools up here. And then some of these ones are just from the cabinet that I haven't used. They were just kind of props. But all these different indexable end mills are all a little bit different. It's actually a pretty good idea of the different types of tools that are out there. Man, we got lots of good tools here. But so if you guys just have face mills laying around the shop and you grab one and you don't know which one to use, you got to be careful because there's different types of mills meant for different types of projects. One of my favorite guys just laying around is just a regular shoulder mill. This one happens to be a Seco, and it's a square shoulder mill. It's got a very positive rake angle. So it's got a positive axial rake. So my insert is cutting, very positive geometry. This one's really made for aluminum. It's got a positive axial rake. It's got a positive radial rake going this way. And so it's super aggressive and it really chews through the aluminum. And I love this guy because it's got a lot of inserts, small diameter body. But with this style of insert, this 90-degree type of mill, in general, if I'm really going to town, my depth of cut isn't going to be more than about half this insert. So with this guy, that might be 12 millimeter insert length or something. I might not go more than 5 millimeters depth of cut on this guy. And same thing here, similar style here. Another shell mill here, shoulder mill. Same thing, real positive axial rake, positive radial rake, really aggressive for aluminum. This one's going to have a great ramp ankle, this Iskar here. But again, if this insert here is, I don't know, if this guy here is looking like 25 millimeters height of the insert, generally with this style of body, I'm not going to go more than about half of that as far as my depth of cut goes. I'll take a full wall if I'm just shaving a wall. And the beautiful thing about these is they can go right up against a shoulder. But that's totally different than like a face mill or a shoulder mill like this guy that has tangentially mounted inserts. These guys are pocketed with backed up, and this thing's meant to go full depth of cut. So actually a lot of these guys has to do with my depth of cut and kind of my feed rates. These guys I might run, I don't know, 6 to 10 thou, well on aluminum more than that, but my depth of cut's gonna be about half my insert height. On this guy, I don't care. This thing's got such nice pockets, I'm gonna go full depth of cut. If this thing's a 12 millimeter insert, I'm gonna go 12 millimeters deep and bury this sucker. Maybe a smaller radial cut, but this thing with these tangential mounted inserts, you can just bury this sucker. And so it's really good if you've got that style of cut, as opposed to something like this, which is a high feed. So Walter, what is this? Sandvik. So this is a high feed mill, and if you picked up this guy and tried to go half the insert depth of cut, you would probably blow something up. So with this type of insert, this probably has like a 10 degree or whatever, these angled feeds here. You don't want to go past this lower edge with your depth of cut. So on this tool body, maybe 40, 50, 60 thousandths of an inch depth of cut. So real shallow depth of cut. But because you have the chip thinning going on, your chip load, your feed rate is through the roof. So this guy is meant to go really deep, right, with a kind of a standard chip load, maybe 10 thousandths of an inch. These guys can go about half the insert, but they're beautiful on a square shoulder. This guy goes really shallow, no deeper than this on my depth of cut. So really shallow depth of cuts, but screaming fast feed rates. Where the chip load on these guys might be 6 thou or 10 thou, this guy might be triple that, maybe 30 thou, 0.7 millimeters per tooth per revolution. So there's totally different approaches to how you remove material. And even this guy is different. This is almost more for cast iron, but it's got a negative rake angle here, negative rake angle there, and this is an octa mill. And so this one you might have feed rates somewhere in between these two. So if this chip loads 6 thou and this one's 30 thou, this one might be 15 thou. So it's really going to get aggressive. It's going to be hitting the material on this 45 degree angle or 40 degree angle on that side of that insert. And because of that, most of the force when it's machining is going to be coming at that angle. So it's going to have side load on the tool and Z-level load on there, which it's going to give a nice surface finish, great for the cast irons. This guy, because it's really only cutting on this angle, all the forces are going at that angle, which means almost all the forces are going up into the spindle. So depending on your machine style, that might be a good thing. With these guys, almost all the loads are going sideways. So this is great for thin-walled material and stuff. So awesome. This is a good tip of the day. At some point, we'll want to look and see what the different inserts are, what the angles mean for your machining, which ones take more horsepower, which ones are less, what's a good style face mill for different types of setups. Man, there's a lot of stuff.
There's a ton of stuff. Yeah, that sounds like a tip of the day for sure.
Yeah.
Yeah, maybe a Haas U.
Yeah.
Okay, I gotta let you guys know, during the middle of that awesome intro, we crossed 150 simultaneous viewers.
Cool.
Thank you, Instagram.
Very good. So we got a lot of questions coming in. Michael Veneti, I guess. Where do you get the right speeds and feeds?
There you go.
There's an open-ended one.
There you go. So go to the Haas YouTube site, check out our Haas speeds and feeds video. We have one in both metric and inch, and we go through all of that. But in general, just generally speaking, my chip loads, how much I go per tooth, my feed per tooth, a lot of times I just make them up because I'm kind of used to different materials. But I do not mess around much with my surface footage, how many RPMs I'm running. I almost always go to the books on that when I'm running production, because the coatings on the insert make a huge difference. If you get the RPM wrong because it's got a coating different than what you thought it had, you're going to burn up your insert. And so the RPM has to be just right, and for that you really have to look in the book for your insert. So for any type of production run, I'm always going back to the book and I'm looking at the type of insert, the coating on the insert, and getting my surface footage, my RPM based on that. But check out the video, Haas YouTube channel, speeds and feeds, and we've made an entire video that talks about nothing but that. How to calculate your surface footage and your RPMs and the chip load and the inches per minute, millimeters per minute. And so we've gone pretty in depth on that. In general, like I look at something like this, if I was going to spin this thing right now, it's aluminum. It's an indexable end mill. I'm going to run this thing at 4,000 surface foot, and I'm going to start out at I don't know, 6 or 10 thou per tooth. but that's just because I've kind of gotten used to those numbers. So this big 4-inch mill might run 2,000 RPMs, 3,000 RPM. This guy I'm going to run at 10,000 RPM, maybe 240 inches a minute. But again, the books will only take you so far. I had this setup guy, Mo Ismail. We were doing automotive work, and I was running castings for aluminum engine blocks. And it was a tool very similar to this. And I got my speeds and feeds, and I was running the tool at 12,500 RPMs. You know, whatever I was, 400 inches a minute. And he's like, right off the bat, he's like, that's too fast. That's too fast of an RPM. I'm like, that's what the book says. It sounds great. I'm running it. Well, it turns out that he was changing the inserts every other day on that tool and on a production machine that had 100 other tools. And so he was spending too much time changing inserts. I lowered the RPM on the tool from 12,500 RPM down to 10,000 RPM, you know, adjusted the feed rate accordingly. The program took a couple seconds longer. And what happened is those inserts that were lasting 2 days were now lasting more than 2 weeks.
There you go.
That's it. I dropped my RPM by 20% on this material, and my tool life went through the roof. So a lot of it comes down to playing it by ear, and if you're running production, things get easier because you've got more time, more parts to get your numbers right with.
All right, so we have another question. This is, I guess because we just spent so much time looking at mill tooling.
Yeah.
M. Baumhorst asks, why nothing about turning?
I know, exactly. We got these guys right here.
I think next time we're going to have to do it.
We got so much. So it's funny, we got to get more stuff on turning. This is there's so much to talk about the lathes. We just finished a complete series on lathe certification. So very soon you're going to see available a lathe certification video series where the lathe has been tied up making those videos. And we intend to make more and more videos on turning. So you know, check the Haas website. There's going to be a whole bunch of stuff coming down the road on turning, and we do tons of that. And there's so much cool stuff out there. And you know what's weird? Have you guys seen the Sandvik prime turning stuff? It's a very weird. We're going to be doing some test cuts with that, where the insert will run backwards and kind of drag across the part. That type of chip thinning on the lathe is the exact same type of thing we're talking about here, where it's got a real shallow angle, you know, approach on this high feed mill. And so with the prime turning on the lathes, what it's going to do is instead of cutting forward with the front of my insert, it's going to come in, down, and then drag backwards. Why does this matter? Well, on the lathes even as well, you can triple your feed rates. And so it's the same thing, prime turning on the lathe as high feed milling on the mills allows you to have incredibly high feed rates, and it can be super productive. But again, definitely, half the machines we sell are basically lathes, and we've got a lot of people turning. So we definitely need some more videos on that, and we will be hitting that. So keep your eyes open for that lathe certification video.
On that same question, Scott Watrous asks, is it reasonable to buy an ST10Y and use your classes to make parts if I've never had any experience with it? Like no experience turning. That's a hard question right there, I suppose.
It's like anything else. It is. I don't know why. There's always been mill guys and lathe guys, and they've kind of, you know, never been the same person. It's more likely to have someone who does one or the other. But the lathe is awesome. They're just so fun to run, and especially if you're teaching it or something like that, you can start out with just simple geometry, and work your way up from there. And in a lot of ways, the y-axis, if you get an ST10Y or an ST20Y like this one, the y-axis makes it easier to run, I think. In the past, if I had to get an insert on center line, I would have to adjust some cams on my bolt-on turret tooling and to get my tools perfectly centered with the spindle. Now, with the y-axis, you can kind of set a tool offset for any one of my drills or taps or even turning tools. And it makes it easy to adjust tools in. So from the setup guy's standpoint, like me, programming, running the machine, y-axis lathes are awesome because they're just so adjustable. You can get your tools perfectly on center and just set the tool offset and run. So it sounds like a y-axis lathe is much more complicated, and it can be, but within days you're going to realize it's actually much easier to run than a standard XZ lathe.
I did see a question. I'm calling an audible about what is the website address for the certification.
Hey, look at that. I got that same one right here. What is the website for the certification classes? And that would be learn.haascnc.com. Learn.haascnc.com.
And that's the same spot where we'll be loading the lathe
certification program.
also very shortly.
That's right.
Very cool. That's a great
We
question.
got another one that I can field. Power Mill CNC asks, where is your mustache? I'm assuming that must be about me. Well, I was last week I had the Corona beard going on, but I figured it was getting really itchy and time to shave it off. So, and I don't know, maybe we'll bring the mustache back in the future. Changing gears. Baz 6016 asks for more fourth axis rotary videos, please. And that's funny because we've talked about rotary.
So we actually we have some demo units and we've sold them off. We're ordering some more rotary units for ourselves. You guys don't care about this, but just to say that even this morning, we were talking about getting some rotaries here, talking specifically about how to set work offsets, how to set tool offsets, how to program these type of things. And even just this morning, we were talking about where do you put the probe, the table probe. A month ago, we made a video on how to put the table probe, tool probe, in a spot that doesn't get in the way of stuff. And so what do you do if you've got a rotary? What's the best place to put that probe? And so we're looking at making a video on that as well, show you a bunch of different options that'll give you, the best location for that. But again, we understand that machining on rotaries can be scary, and there's really just a handful of steps to get you there, and it just becomes like running anything else, any other 3-axis mill. And so we're absolutely kind of lathes and rotary products are on our radar. So we'll be hitting more of that lately.
And for the folks who are also talking about, learning how to machine on their own, reaching out to your HFO is probably a good idea.
Yeah,
and getting out to a classroom and getting your hands on a CNC machine. We talk a lot about that in relation to the certification courses.
Yeah, that's right, for sure. I'm going to go back to a question from last week. This one was from Dat606. And he asks, does a warm-up cycle have to be run daily?
No. Yeah, it's always a good idea. It depends on your spindle, but generally speaking, if you didn't run it every day, it's not going to be a big deal. Certainly, my Monday morning routine is to come in and run the spindle warm-up program on a machine. So it kind of depends also where you're at. If you're in the Midwest and it's 10 degrees outside, and you're coming into a 40-degree shop every morning, yeah, I'm running the warm-up program every morning, just to kind of get those greases flowing. Here in Southern California, it's 72 degrees all year round. I tend to, for years, I ran the warm-up cycles on my spindles every morning, and then it depends on the operations I'm running. I think it's a good idea.
Like you said, if you're coming in for the weekend, then the spindles had a chance to sit for 2 or 3 days. Yeah. Then you're concerned about getting lube to the spindle. It's not just warming it up. Yeah. But if it's every morning, probably not. Yeah. If you have the time to do it, doesn't hurt.
Yeah, exactly.
Okay, so next question. This was, I think this was from last week as well. Jeremy Godsey62 asks, is it possible to probe in a tool room mill? Hey. New to probing and touch off the old-fashioned way. Of course it is, right?
Yeah. You don't want to mix the two. You don't want to probe half your tools and touch off manually with the other half. You want to stick with one or the other. But certainly the probing option is available on tool room mills, even our little CLs and stuff. We got probes in those guys, and they work beautifully the exact same way as every other Haas mill out there. And so for sure, probing is available on all those machines, and it's awesome.
Yeah, and I love that you guys tossed out a question from last week. So we are looking at those super close, and if we don't get to it this week, there's always next week.
Yeah, that's right. Keep sending them through, and we'll keep looking at them.
Yeah. Speaking of a question that came in right this second, Wixo92 asks, hi Mark, can you make a video about G-code G12 and 13?
I know, right? Exactly. Okay, so G12 and G13 are for creating circular pockets, and they're just fantastic. So if you ran other controls, you've probably missed having those G12, G13 cycles. They are awesome. yeah, we'll definitely hit that. So the nice thing about that cycle is just really quick. You can punch a hole, come in and interpolate a circle with all the roughing passes built in with your D and K values, and it's just a really nice way to make a pocket. Yeah, we'll do it. We'll put that on the list, and we will get it coming in.
Nice.
Just want to say thanks to everyone that's online. We've got viewers from UK, Iran, Serbia, Tajikistan, France, Peru, and the list keeps going. I can't even see half of them as they're flying by.
And also from Russia, which is really great because we had some folks last week talking about...
That's right. It means there's some people up late there watching this, which is fantastic. We're glad you're joining us.
Thank you.
This is actually a question that from several weeks ago that I will tender. This is from The Matrix Revolution. Will you ever make service parts again for older machines like a 1994 VF3? And the answer is, if you go to haasparts.com, you'll find a huge array of parts. Unfortunately, back to 1994, there aren't very many parts. But going back, I was just checking this last week, and I searched on 1997 VF2, VF4, those series of machines, and there's a wide array of parts for machines going back to about 97. Axis parts, weight covers, tool changer parts, motor parts, control parts. So there's a pretty great coverage, and that's considering that that's many iterations of major design changes on the VF machine. Pretty fantastic that you can still get that many parts for your older machines.
Now, creeping around the corner here, Mark, I noticed that you brought in some Band-Aids?
This is leftover stuff from last week. Last week, Tyler and I shot a video. It's the dumbest video ever, but I love it. My first week as a machinist, it was horrible. We were running golf putters, so the shop did a lot of different type of work, and I was running toes and heels on these Odyssey putters, and I kept cutting myself. Everything I picked up, I cut myself on. And after a week in the shop, I thought, I can't do this. I'm not going to make it. And things got better. By week 2 and 3, I could stick my hand in glass, right, and not get cut. You get used to it. But still, how machinists take care of their hands and keep machining, keep working, is a big deal. And so we actually made a video last week, and it'll be edited and published soon, about Band-Aids and all the different tricks you can use to custom cut a Band-Aid to have it do what you want, and then also how to keep your hands from getting infected, how to wash them and clean them, what the newest, stuff on that is. So that's what all these guys are, and there's some really cool things out there.
Yeah, we'll keep our eye out for that when it pops up on YouTube.
Yeah.
All right, this is one that might go down a rabbit hole a little bit. This, I believe, was from last week as well. Morgan Olaf asks, hey, I would really like to know how G4142 affects actual feed rate when cutting an arc. Is the feed rate automatically applied to the contact point instead of the cutter center line?
So G41, G42, how is it?
Is the feed rate automatically applied to the contact point instead of the cutter center line?
Gotcha. Okay, so this is like machining, not machining 101. This is machining 201. It's 401. This is a problem that every machinist comes across, in their first few months machining, and they have to figure out fast before they start breaking tools. Let me do this.
All right, we're bringing the whiteboard back.
Yeah,
I love it.
Okay, so I might be misunderstanding the question, but in general terms, if I've got a it works. If I've got an end mill coming in here and I program it here and it comes in and it machines here, and then I come back here, weird things happen in corners. And so even if I've got a corner like this that's rounded, the center of my tool path is actually more like this. So this is my center of my tool path right here. That's conventional milling. But if I'm coming this way around, if I'm coming in at 100 inches a minute, something really weird happens here, because that feed rate, when you program it at 2,000 millimeters or 100 inches a minute or whatever, as my tool comes through, all my feed rates are based on not my part edge, but the center line of my tool. My tool is here. My tool is here. My tool is here. So my tool is moving 100 inches a minute at the center of the tool, not where it's making contact with the surface. Now this becomes really important if you're using let's say a 1/2 inch end mill. half-inch end mill to create a hole that's only 0.6 inches diameter. So a half-inch end mill, 0.6. Because the tool path is really just making a little tiny circle 100 thou diameter. So you tell that to go, 10 inches a minute, and it's actually going much, much faster where the rubber meets the road, where the tool touches the edge of the profile. So if I was looking at this half-inch end mill, 0.6 diameter hole, sorry if I'm making this more confusing than it needs to be, but what you'll do is you'll take the diameter there versus this, so 0.6 divided by 0.1. Yeah, it's 6 times faster. So if I think I'm going 100 inches a minute, I'm not. I'm going 600 inches a minute where the rubber meets the road. All this is to be said is that the machine cannot know. There's nothing we can do with the control to know how fast we are going where the edge of the tool meets the contour, because we don't have that information on the control side. Your cam system does, though. If you've got something like Master Cam, you can go under arc filtering, underneath arc filtering, and there will be override radius feed rates, something like that in the cam settings. And what that's going to do is it might give you 100 inches a minute, on this line of code right here. And then on this line of code that just takes in this corner, it's going to slow it down to 12 inches a minute or whatever it's going to be to keep the surface contact feed rate the same. So cam systems now, just in the last few years, are adapting this for us, and it really has to come from the cam system. So lots of modern cam systems now have it built in where they will lower the feed rate in corners to keep the feed rate constant at the point the tool meets the profile. And nothing we can do about it in the control, because the control doesn't know where your part is. And it knows all the control knows is where the center line of the tool is. So all feed rates are based on center line of tools. And so if you're coming in with a G12 or G13, we talked about it earlier, if you're coming in with an end mill and you're creating a hole, be really careful with your feed rates, because you're going to could be going 10 times faster than you think you are where the edge of the end mill meets the side of the hole. And conversely, if I'm going around the outside of a part, you're probably getting really nice finishes, because when you're going here, you're actually going slower where the end mill meets the contour. So that'd be a good video at some point.
Yeah,
yeah.
Fantastic.
So
cutter comp and
cutter comp. The short answer is the machine doesn't know how fast the tool is actually going where the edge of the tool meets the part. The cam system has to do all of that, but a lot of modern cam systems have it built in. You'll post out your code and you'll see different feed rates for every line of code depending on the size of the arc that's being machined. And it does give you a better sounding cut. Nice. And it'll give you a more even surface finish on the part.
And I love that you're teasing it up here, and then we're talking about making a full-length video where we can dive into the details later. Nima Garan is asking a lot of great questions about the certification. Is it free? How does it work? Maybe, Andrew, you might be able to speak a little bit to the certification.
Yeah, I mean, the basic idea is you go to learn.haascnc.com and you sign up for the certification class. Right now, we just have the basic mill operator. Soon we'll have the lathe operator class as well. From there, you watch a series of videos where we're giving you the instruction, and then for each one of those videos, you answer a set of questions. Once you get all those questions right, you can move along to the next video. You can take the test as many times. Each of those tests you can take as many times as you want. When you finish the entire series, you're then congratulated, and you're prompted to submit a request to meet at the HFO for a hands-on test, as we call it. And this is kind of your chance to show that you have spent a little bit of time in front of a machine, because one of the things we repeat over and over again in the operator series is that you can't just take the videos online. You have to actually get in front of a CNC machine, or else you just don't have you're not going to be ready to go to work. Right now, with the present situation in the world, COVID-19 and so forth, the HFOs aren't doing any of the hands-on testing. So we're going to have quite a backlog, I think, when we can start reducing the social distancing. But it's still a great opportunity to take this test. It still gives you lots of great information and and allows you to get your feet wet.
And totally free. All the videos.
All of it's free. When you go to the HFO, they'll typically charge you a nominal fee, $50, $75, $100, something like that. But compared to the cost of most other programs out there, it's essentially free. So pretty great opportunity, and you have nothing to lose. Lots of great information.
Thanks for asking that question. Thanks for that rundown, Andrew.
I actually have another question here from Dalton 527762, and he asks, or I'm assuming can running a machine hard cause it to lose accuracy over time?
Can running a machine hard cause it to lose accuracy?
Whoa.
Band-Aids. We got a whole thing coming up on this soon. I know, it's magic. Look, and they can't come off. Look at that. It's perfect. Put a glove on. You can run with coolant. Watch the video coming up in the next couple weeks. Does running a machine hard make the machine lose accuracy over time? Yeah. There's a difference between hard and stupid. So I run my machines when I was in a shop. I ran them 100% spindle load like all day and all night. And if I had to replace a spindle every 5 years, it wasn't my money. If the owner of the company had to replace a spindle every 5 years, do you know how much money we made off that machine in 5 years? We pushed it hard and we did maintenance on it. That was the way it should be. There's a difference between pushing the machine hard though, 100% spindle load and that kind of thing, and pushing it too hard. In the same way that my lowering the RPM from this guy from 12,000 to 10,000 RPMs allowed me to change the inserts every 2 weeks instead of 2 days. There's a point, and there's no way to explain it, but you can hear when the machine is going, when it's rattling, when you are driving it so hard that you're breaking something. People abuse their machines, and you're going to break it. Yes, you will start wearing things out if you are running the wrong tool or pushing a tool too aggressively. Or usually what happens with us is you're running a very long end mill, ridiculously long end mill, and you're running 100% spindle load, which is fine, but there's so much rattling going on because you're running these silly end mills, and everyone in the shop hears it. You can hear this thing banging around. That's not good for the machine. Yes, you run it like that day in, day out, it's going to affect the accuracy of the machine over time. And there's this happy sound. Just lower that that feed speed 10%, and you can hear that nice happy growl from the machine, and the machine's just going to run forever at that point. So I run my spindles, I run my machine full bore, full depth, full everything as hard as I can all the time. But there's a fine line between running it hard and running it excessively hard. And so if it's not,
you've got your ear tuned up to know what that sounds like, and you're also you know what the kind of parameters of whatever tool you're using. You probably know about where you should be to not to not be abusive and just be productive.
Yes. So yes, you can absolutely abuse a machine. That's the short answer. The same way you can abuse a car. You run that thing at like that Ford versus Ferrari movie, right? You run that thing at 7,000 or 8,000 RPMs. It's not going to run all day long. You run that thing at that's an engine. Now I'm not talking about RPMs. On our machines right here, I'll run this thing full RPM all day and all night. If I have a 10K spindle, I'll run at 10K. It's not that I'm worried about. It's about the beating it around in an interrupted cut. Weird things like that. The machine should be feeds and speeds need to be adjusted to reduce chatter. If you're getting heavy chatter, heavy noises like that, it's certainly not good for the machine. But that's the case with any tool you use. When something's making terrible noises, you adjust something to make that noise go away.
Speaking to the same issue, Tom Hindman asks, what breaks first, a tool or the spindle on a tool crash, usually? Well, first off, if you're going to crash the machine, have the spindle turning, please. Let's start with that, right? Because otherwise you're going to Brunel the bearings like that, and you're going to replace your spindle. So if you're going to crash it, make sure it's turning.
Yeah.
Almost always, right?
If you're running solid carbide tool and you broke an end mill, the spindle's just fine. You're spinning up at RPMs. And what Andrew was just saying, one of the worst things you can do is be jogging around the machine. It seems like nothing, or the spindle stop, and then you wrap it into a vise. The spindle's not moving. The ball bearings inside the bearings are going to put a big dent in the race, and it's going to harden in that spot, and they're going to get this click, click, click every time the spindle goes around. If the spindle is turning, you're usually just fine. If anything, it's an alignment issue with something else that moved, you realign the machine and you're up and going. Yeah, but I don't want to say this. I've broken plenty of tools, and I've crashed plenty of machines. Crash is a excessive word.
Nobody's watching, Mark. Don't worry.
Yeah, no, they're fine. Yeah, and it's usually on like, op number 17 when the part's just about done and you're about to say something else. All I gotta do is finish this little bit of engraving and you're fine for the most part. It's you're definitely gonna break an end mill, like an end mill or a drill, long before you break the spindle, or have any problems with the spindle. You'd have to have a pretty heavy crash on a mill body to cause spindle problems.
Well, we're just about to wrap this up here. I just want to say thank you again to everyone who's on the feed here. We've got people from all over the world: Malaysia, Belarus, Brazil, Argentina, Israel, England, Dominican Republic, India, Nigeria, Italy, Tajikistan, as I said before, Iran, as before, Russia, and Peru, and Colombia. So thank you very much, everyone. Obviously, machining is a worldwide pastime or form of work.
Yeah, and we've been hovering up around 100 simultaneous streams, so we couldn't be happier about that.
Yeah.
And so many great comments. Thanks, everybody.
Anything you want to wrap up with, Mark?
Yeah, again, that email address for next week. There you go, right here. TOD@haascnc.com. If you've got a question, we'll get to it next week. Send it to us. And when I woke up this morning, I was thinking about one thing. Why do we make the tip of the day videos? So when the general manager and the owner of the company started this video series, I can't say what their intent was. They wanted to get all the information they could out there. But in some weird way, I think that a lot of these videos that we make are there to remove tribal knowledge. We want to get anything that all of us know into the hands of people who don't have somebody talking to them, no mentor in their shop speaking to them, that type of thing. And so if you have a question, anything you want to know, we're an open book. And we've got hundreds of machinists who are better than me back at the factory, right? We have our own machine shop. We make parts. And if I get stuck, I've got 50 people I can go and ask a question to. And if you have a question and you want an answer to it, shoot us an email at tod@haascnc.com. And if I don't know the answer, I'll find someone who does, and we'll reply either via email or via a tip of the day or via one of these tip of the day lives. That's it. We'll see you next week.
Thanks, everybody. See you next week.
Thanks.